Hey everybody, I've done a bit of work this week that I'm really excited to demo. What I'll be doing this video is doing a quick demo of most of the stuff and then going through a more detailed demo and then some of the code. But yeah, with the quick demo I won't talk over, I'll just let the gameplay play out. So I'll just mute the mic and enjoy. So I hope you enjoyed that quick demo of almost everything I've worked on this past week. Uh, Now I'll just go into detail the rat. So first before that, I'll show you one thing I forgot to show, and that's the level transition in the console. So if I go, as you see there, I'm just going easily through each level. So just for development, a bit easier way to switch levels. Yeah, for the rat, this took up most of the time this past week, and that was instead of using the 3D model, which I couldn't get the animations to work on, I just turned it into a sprite. So the sprite itself, it's still a 3D model, so OBB still applies. I've just done a plane, so it's just like I guess it works like a TV, but it's a plane that's always facing you, and then that plane outputs the image based on where you are in relation to where the enemy is aiming. So this rat is just a neutral NPC, so he's just going to roam around. In the final game, they're just going to be there roaming through the trash. but the enemy NPCs will have the same logic. So here, like, this rat's aim direction is just in Z equals 1 at the moment, but if it was to aim here as well, it would base what it draws on where you are in relation to that aim vector of it. So here I'm behind it, draws behind, and it does the animation there. Same with this angle on the side, at the front. So there's 8 angles in total, and that's going to be for every enemy. It was a painful process, but I think it was worth it. And then there's like 15 images per angle, and that was that same model's animation. So ideally I wanted to have these animations in that 3D model, but yeah, couldn't get it to work. So just implemented that, and that's pretty decent, I think. I added a 1 pixel black line around it as well. I think it works well instead of having it just the model, because it's a 2D image, and what I've found in personal preference, just the model that looks 3D, but it's on this 2D sprite, it kind of looked weird. So having this black line around its edge kind of, well, for me, it tricks your eyes into knowing, yeah, this is a 2D model, but hey, it doesn't look too bad that it's supposed to be a 3D model. So I thought in the end it looks alright, just like that. So most of the models, I think I'm going to have just this black line. The only downside is on that tail, kind of looks a bit choppy. If I switch the FOV, you can see it a bit more. And that vibrating is just because he's colliding with the, oops, that's the music. That vibrating is just because he's colliding with the ground. So yeah, that's the rat. That's everything with the rat I've worked on. Another thing I wanted to demo with the entities, so not just the rat, but any enemy entities that are going to be in the game. I've improved the Entity 2 model collision detection. So if I switch back to turn off VSync, previously, so there's 50 enemies here in a line at the moment. Previously that would have been a decent performance hit. And that was just because I temporarily had each enemy check in collision against the whole world, and that's the same in Battle Court. It's kind of, yeah, it was resource intensive. Now it's using the grid system properly. Same with like the player and bullets. I just hadn't applied it yet to the entities. So like here you can really see the difference. So before applying it, it dropped the FPS to like 50, which is not good. But now, yeah, even with 50 enemies, so we got like 50 enemies, we got these 45 things moving around, we got the models, there's like a big grid of these floor models at the moment, and the FPS is holding pretty nicely, 180, yeah, around that, 170, 180, there it dips a bit. But yeah, like at the moment I'm pretty happy with that FPS, because it's a massive improvement even over Battle Court's code, and this is even now in a 3D engine. So yeah, maybe there'll be more improvements I can make over time, but yeah, in its current state, at least I'm more confident with when there'll be more models, more enemies, it won't affect the frame rate too much. So that's just the other thing with the entities, which I'll go through in code as well. So what I wanted to show in code was just the sprite sheet effect that I'm using for those 2D models in the 3D world, and how I'm getting them to draw at different angles. So what I'm doing is simply, it's a 3D object, a plane that rotates, it rotates to always face the camera, and that's simply this, rotate, the model's rotation is equals the camera's rotation, and then I'm just setting the OBB so you can still collide with it, and then the sprite plane is that. So all this is yeah, we've got a plane, and that's always facing the camera, and that acts like a TV drawing the texture that you provide through the sprite sheet effect on that plane. And then yeah, with what it outputs, we can then work out based on the entity's aim direction where you are in comparison to it. And then in the sprite sheet effect as well, we say, all right, it's, you know, you're maybe standing behind it and to the left, so we draw the behind and to the left angle of the animation. So it's just that. So all this is yeah, that rotation. And then here we've got, so this sort of added this week the model texture, and that's segmenting. So this is both the sprite sheet effect happens here and calculating the angle that it should draw. So for the sprite sheet effect, we've got this array here. I'm using one-dimensional array. It could probably be a two-dimensional array. It may work better or may look neater in code, but yeah, for now anyway, it's just that. So this is the sprite sheet code here, which it segments the full texture image, which contains, like, so for me, I've got 15 frames of a walking animation, and I've got that in each of the x-axis of the image. So like you've got the frame 1 of the rat walking forward in the top left, and then next to it is the next frame of it walking forward, and so on. And then below them is the next angle, so maybe like front left, and then the same frames, and then to the left is under that. So it's 15 times 8 images in that one texture image, and then this iterates through that and determines what. So well, this just splits it actually, sorry, it just splits it into a single texture that you want to see, and outputs it in an array. So here where we can see that split, we see we just pass it into this texture parts array, and then we just to go through that, we just are using it here when we're setting the texture. And this, what we do here is return, so this current texture part x and y is determined up here, which I'll go through after this. But this, to put it simply, it's just this is the current texture that should be output to the plane. So here, and this is why I mentioned maybe you could use a 2D array in this split or in this texture parts, because then you just pass in the x and y coordinates into the array. But yeah, here I'm just kind of totaling it. So like instead of x0, y1, if it was a 2D array, in this array it would be, so let's take that example of 15 frames in the x. It would be texture part 16 would be the x0, y1 in that texture grid sprite sheet that I've got there. So that's all that it is here. And I'm just, yeah, one-dimensional array still. So this simply just sets that. This is the core of it. This here, I'll just quickly look through if there's anything else I need to mention. I don't think so. So yeah, what we're doing here, the update sprite plane, this is, so this is to determine what angle to output the image at. So there's two parts of this to determine the angle. One is this is why I'm glad I did it after the sound pan, because you need that pretty much the same code as the sound pan. So that's here, this one, the difference. So here I'm just getting the difference, which is your player. So the difference is your position to the model's position, and that's that plane that rotates to always face the camera. So that's this difference. So that's one vector you get, which is from the player to the model. Then we just normalize that, and then we just get the magnitudes. Oh, sorry, this. Okay, that's the second part. But here we just get. So once we have this difference, we get the cross product of the model's aim direction. So whatever that may be, let's say. So in the example in the demo, the rat was just walking forward in the z-axis, so z equals 1. So this aim direction is just, for this example, let's say it's just 0, 0, 1. And then we cross that with the difference, which is, that vector that you grab your position to the model's position, and that gives you the cross product. So we're doing the exact same thing for sound pan, but here what that will do, it outputs whether you're, I was going to switch to Photoshop, but I don't think the recording software picks up Photoshop for some reason, unless I switch to desktop mode, but I haven't set that up properly. So if you can imagine just a two-dimensional Cartesian plane, I don't know if I'm explaining that right, but you've got the X and Y axes. So with cross product, the Y, you'll see the Y axis just acts as like a split. So to the left of the Y, you'll see it goes, so if the cross product is, say, on that Y angle, you'll get something like a 0. But if the cross product is directly facing to the left or right, you'll get either a -1 or a 1. And then the same if the cross product is facing down in that XY coordinate thing. Sorry if I'm not explaining this well, but yeah, that's with cross product. So yeah, facing up, you'll get a 0. Facing down, you'll also get a 0. And facing left and right, you'll either get a -1 or a 1. So with that, you can determine if you're to the left or the right of the model. So that's one thing you can grab, but it doesn't give you enough information to segment. Yeah, even if you're doing the 4 directions, just that won't be enough, because whether you're standing in front of it, it'll output a 0, and whether you're standing behind it, it'll output a 0 as well. So what you can do with cross is just at least determine whether you're on the right side or left side. And then you also grab the angle between the two vectors. So this was another thing I tried with the sound pan, and if you get only the angle doesn't matter if you're to the left of it or the right of it. So like if the difference in the aim direction may be, how do I say this, like right facing, let's say, it'll be just output the angle. But if it's the difference in the aim direction may be left facing, it'll still be the same angle, but you don't know whether it's to the left or the right of the aim direction. So with both these things, finding the angle and finding the cross product, you can determine what angle you're at correctly. So here like I've got the cross product. So if cross y is less than 0, then we know we're on the right side. So the cross product will be a range from 0 to -1. And then here we've got the left side, the cross product will be a range from 0 to 1. So that with that we know we're on the right or left. And then we just get so now with the angles, we get the result of the angle. So if the angle is less than, and I'm using radians, so Monogame framework's based on radians, but this is math.pi over 8. So because I'm segmenting it by 8, if you visualize kind of 8 segments, so here, because the front and back is kind of cut in half, we've got this front segment's kind of 1/8 of pi. So in radians, if you don't know, the full 360-degree rotation is 2 pi. So to segment 2 pi by 8 is pi on 4. But yeah, we're getting half that, so pi on 8, because this front is the same as this front. It's just split between left and right. And then so yeah, if angle, this result of this angle, which is the magnitude of A and magnitude of B, which is the so mag A is the difference, the magnitude of the difference vector, mag B is the magnitude of the aim direction, and then to get the angle is the cosine -1 of the dot product of those two vectors divided by the magnitudes of those two vectors multiplied. So that gives you the angle. So here, yeah, if the angle is less than pi on 8, then current texture part Y is 0, which is so in my sprite sheet, it's just the top line. And then like front right isn't near the bottom of the sprite sheet. So this current texture part equals part is arbitrary to whatever your sprite sheet setup is. So yeah, like front is, so if you look at it here, front is between, let's just say -pi on 8 and pi on 8. And then here we've got the front right, which is between the pi on 8 to 3 pi on 8. And then right is from 3 pi on 8 to 5 pi on 8. And then yeah, back right 5 pi to 7 pi. And then back is 7 pi on 8 to also like the exact same but on the left side. So if that's making sense, that's pretty much how I segmented it to output the correct angle. So those two things you need, which is the cross product of the two vectors, those vectors being the aim direction of the model and the difference between you and the model. And the other thing you need is the angle between those two vectors as well. So I hope that explanation is useful. Yeah, that's the only other thing I wanted to show quickly in code is just the collision. So I've moved it here, model to model collision on grid. So this is used also for the bullets now. And the only other things at the moment is those bouncing cubes. So yeah, and that's just that grid system stuff. So yeah, that's all I wanted to demo in code. Thanks. And next thing I want to demo is the console commands. So you saw that level transition I showed quickly. And yeah, that was pretty straightforward. It just calls the same level change code that, say, when you interact with a door. But yeah, so if I press forward now, it'll be going in this direction. But if I look here, so you see it preserves that rotation. So that's just one, the bug I have to fix. I'll just quit the main menu to restart everything. So as well with the console commands, you saw the time dilation stuff. So if I do, we have this, which slows time 10 times. So pretty much 10 seconds in this is equivalent to 1 second in normal time. So that's applied to, pretty much the entire world, like these falling effects, so gravity, the rotation, so like on this door, the sound effects, so that footstep, these rotations, that collision still have to fix. The bullets, and the only thing it's not applied on is your player, and that's just mainly at the moment because there was some issues with the collision, and also when it was applied to the gravity on the player, it would be like you were jumping on the moon. So like with normal gravity, you're jumping normal like this, but if time dilation applied to the gravity of the player, you would jump 10 times the height and fall at a slower rate. So for now, I've decided not to apply it to the player's movement. So that was one console command which slowed time by 10. And then we have, so this one which applies time dilation by 100. So 100 seconds in this is equivalent to 1 second in the normal time. So there we can actually see the bullets. And it's a good way to test the collision as well. So like here you can actually, what I tried to do in the quick demo as well, climb up this. But yeah, like the collision is applied nicely on moving bodies as well. So like here, even the OBB, you can see it now. So like on this door, it's rotating too slow, maybe this one, I think I put a faster rotation. You can see how the collision works. So like that is a bit choppy, but at least it doesn't allow you to pass through. And then how you can slide on that door. Can't fit through the door yet. So yeah, just as a nicer way to see the collision, even the bullet collision. So like if I shoot here, you can see, so like even on OBB, yeah, it applies the collision nicely. So yeah, that's two. Oh yeah, there's one more thing. One more console command I added. I'll just set time back to normal. So yeah, like here you see a normal time again. Bullets are moving super fast. So that effect as well, it will be an augment probably. So player maybe upgrade their perception, and then when they run that augment, time will slow down. So it's like bullet time. But yeah, obviously you're not running in slow motion for long periods. It would be pretty overpowered if it could be. So something like how Max Payne did it probably, combined with how Deus Ex has its augment system with bioenergy or whatever it was. And then another augment will be this light effect. So because everything will be nighttime, you'll want to have a sort of light effect. but I couldn't get directional lighting working from the player to the objects. So for now I've just got it as this overall like night vision effect. So when you say toggle your eyes augment, you can see better in the dark, and then just some references there to Deus Ex. So light vision's augmented, and who wears sunglasses at night. So just a few little references. But yeah, I mean this is only in the console anyway, so I've only got it in the console for now before I set it to be actual augments or mods, player mods, whatever they're going to be called. But yeah, you'll toggle night vision on and off to see better at night. And then yeah, certain sections of the game will probably be even darker, so requiring that night vision. But yeah, that's all for the console commands that have been added. The last thing I want to demo is the ambient sounds. So here you can hear the nighttime effect. If you saw before, in the slow time there was different ambient noises in the background, and then there's also this footstep effect. I may change that sound, but that's just in for now. And then the bullet collision sounds, which in the quick demo I tried to show as well. But if you shoot, say, the ground, there's just like a tapping noise for now. Some of the sounds I'll keep changing till they're more suited. Or if you shoot, say, stone, and there's just a random pitch applied to it. Enemies, where do you go here? So like if it's hitting an enemy, just a muffled hit kind of noise at the moment. Wood. Yeah, that sound effect was supposed to be an arrow hitting wood, but for now I'm using that one. And then like these are the only things that have metal, so and that was what was previously used everywhere. So yeah, a few different. So now the objects have material types, and then based on the material types, you'll have at the moment the bullet hit sounds, probably footsteps will be different too. So like here, obviously, if it's concrete, you'll hear this kind of more crisp footstep sound. If it's grass, it'll be a grass sound, which I haven't applied yet. And yeah, so just things like that, which the model material type will have use. That's it. So thanks for watching, everyone. I hope you enjoyed this week's work. There's a few things I still, for next week, I know I want to do. That's, rotation. Fix that rotation during the level transition. That shouldn't take, I think that's only one quick fix thing. That move speed when you're moving in the X, it'll max your X move speed or X velocity to say 0.2, and it'll do the same for Z. But if you're moving, say, in a diagonal of that, it can combine, so you move quicker in the diagonal. So I'm going to just change that to be a max move speed in all directions. And then there's certain collision where you're falling through the ground, like if you're colliding with the enemy, and then also the floor, you can fall through the ground slowly. And then also the ramps, I want to really fix that up, because now I think it's because I added the Y, or maybe not, I don't know what I've changed, but you can pass through the back of the ramps again for some reason. So I have to try and fix that. Probably even fix the floor collisions in a better way, because it affects the jump as well. Like sometimes when you press jump, it doesn't detect it if you've previously jumped, because like there's a slight like if you saw on the rat it was vibrating, it happens to the player too, but it's that collision detection. So like if next frame is colliding, then your result vector is bounced up a little bit and so on. So it keeps cycling through colliding with the floor and not. So that's the other thing I want to fix. But yeah, in terms of functionality, I'm not sure what I'm going to work on next though. So yeah, hopefully next week I'll have some interesting stuff to show too. This week I was pretty happy with showing off the rat stuff, or the entity stuff in general, and that time dilation stuff. Even though the time dilation it's a small thing, it's just adding a float to like whenever you're applying movement or gravity or anything. So it just divides it by that time dilation amount. So that's really straightforward, but such a straightforward thing can be something really cool. And then yeah, like the lighting effect on it as well. I don't think I mentioned it, but the lighting effect, which has the red shift on it as well, and yeah, like really even more when you're in the 100 time dilation stuff. So yeah, anyway, that's everything I've worked on this week, and hopefully see you in the next video. See yous.